You studied for days. Every answer was right there. And then the moment came, and your mind went completely blank. You did not forget. Your brain made a decision without asking you. A deliberate, biological decision. That blank was not failure. That blank was your brain running one of its oldest survival programs. A program that was never built for exams, presentations, or high-stakes conversations. It was built for something far more urgent. Right now, inside your skull, two systems are running at the same time. One wants to remember. The other wants to survive. And the moment pressure crosses a specific biological threshold, survival wins. Every single time. This is not a weakness in your character. This is cortisol, your hippocampus, and a 200-million-year-old circuit doing exactly what they were designed to do. Here is exactly what happens, and why it starts long before you even feel the pressure. Your brain does not wait for pressure to peak. It starts shifting before you feel a thing. The moment your nervous system detects a high-stakes situation, your adrenal glands release cortisol. Not gradually. Within 90 seconds, cortisol levels in your bloodstream begin to rise. By minute 3, the concentration reaching your brain is already measurable. Here is where it gets precise. Your hippocampus, the structure responsible for forming and retrieving memories, is lined with cortisol receptors. More than almost any other region in your brain, it was built to respond to this hormone. And at low levels, cortisol actually sharpens recall. Studies show that moderate cortisol enhances memory consolidation by up to 40%. But your body does not stop at moderate. Under real pressure, cortisol does not sharpen the hippocampus, it floods it. Researchers at the University of California found that when cortisol crosses a specific threshold, hippocampal activity drops significantly. The very structure you need to retrieve information starts pulling back. Not because something went wrong. Because it was redirected. This is not a malfunction. This is your brain shifting its priorities. In that moment, your brain is not thinking about what you studied. It is scanning for exits. It is calculating threats. It is sending an entirely different kind of signal to your prefrontal cortex, your rational language-based thinking center. The memories are still there. Every fact, every word, even that perfect thing you wished you had said to your manager mid-argument. They have not disappeared. They are locked behind a biological gate that cortisol just closed. Think about the last time this happened to you. Not just in an exam, in a conversation, in a room where everything felt like it mattered. Did it feel like forgetting? Or did it feel like reaching for something just slightly out of range? That feeling has a name. The mechanism behind it goes much deeper than cortisol. Here is what flips the moment you understand the full picture. You have been told your memory failed under pressure. The biology says something completely different. Your memory did not fail. Your brain executed a perfect switch from a retrieval system to a threat response system. These two systems share the same resources. When one fully activates, the other steps back. Not randomly. By design. The structure at the center of this switch is the amygdala. Your amygdala does not process language. It does not care about facts, sequences, or anything you prepared. What it processes is threat, emotional weight, physical signals, the biological signature of danger. And under pressure, the amygdala does not just activate. It takes over the neural bandwidth your prefrontal cortex needs to think clearly. Research from Stanford's neuroscience department shows that during high-stress states, communication between the prefrontal cortex and hippocampus decreases by up to 30%. 30%. That is not a minor disruption. That is a significant rerouting of your brain's entire information highway. And here is the inversion that changes everything. The stronger your memory, the more cortisol receptors your hippocampus has developed. The more you have studied, the more sensitive your system becomes to this exact shutdown. High performers do not experience this less. Studies suggest they feel it more intensely because their hippocampal networks are more developed, more receptor-dense, and more reactive to the cortisol signal. The people who go most blank under pressure are often the ones who prepared the most. This is not a cruel irony. This is a biological truth that nobody explains in the context of performance, memory, or human potential. So if cortisol is the trigger, what determines how high it climbs? Why does the same level of pressure completely erase one person's recall while leaving another's fully intact? The answer lies in a hormone most people have never once connected to memory. Cortisol does not work alone. Just beneath the cortisol response, there is a second hormonal layer. And this is the real variable that determines whether your memory shuts down completely or holds its edge under pressure. That layer is norepinephrine. The moment your threat system activates, cortisol and norepinephrine are released at the same time. But there is a critical difference between them. Cortisol spreads broadly. Norepinephrine works with precision, targeting specific neural pathways. And at moderate concentrations, it keeps your working memory online. The real-time processing system your brain uses to hold and work with information while actively using it. This is where the tension begins. Cortisol suppresses hippocampal access. Norepinephrine, at the right concentration, keeps prefrontal circuits partially online. What determines whether you go blank or stay sharp is not your stress level. It is the ratio between these two hormones. Research published in Neuron makes this clear. Individuals with higher baseline norepinephrine activity showed significantly better recall under acute stress. Their cortisol levels were identical to those who went blank. The entire difference came down to this 1-second signal. And this ratio is not fixed. It shifts across sleep cycles. It changes based on how consistently you eat within the 6 hours before a high-pressure event. It even responds to the temperature around you in the 20 minutes before pressure hits. These are not small details. Studies showed that a 15-degree drop in room temperature in the hour before a high-stakes task measurably shifts the balance in favor of memory retention. Your body was already calibrating this system before you walked into the room. Before you sat down, possibly before you even woke up that morning, the pressure response does not start when the pressure starts. It builds hour by hour through an automatic biological process, whether you are aware of it or not. But there is one more layer, the deepest one. And it explains why some memories survive the cortisol flood completely intact, while others become unreachable at the exact moment you need them most. This is where the biology gets personal. Not all memories are stored the same way. Your brain encodes information through two fundamentally different systems, and when cortisol peaks, only one of them stays accessible. The first is declarative memory. Facts, sequences, everything you consciously studied and rehearsed. This system lives primarily in the hippocampus. This is exactly what cortisol shuts down. The second is procedural memory. Skills, patterns, things you have repeated so many times, they have migrated out of the hippocampus entirely. Into the cerebellum, the basal ganglia, the motor cortex. These structures have almost no cortisol receptors. Cortisol simply cannot reach them. This is why a musician's fingers still find the right keys, even when they are terrified on stage. This is why an athlete's body executes a movement their conscious mind could not put into words. The only knowledge that survives when the cortisol gate closes is knowledge that has become instinct. The memory did not disappear. The access route did. Johns Hopkins research puts real numbers to this. Information rehearsed to the point of automaticity shows zero degradation under acute cortisol elevation. Zero. The same information rehearsed only to the level of conscious recall shows up to 60% retrieval disruption under identical stress conditions. The difference is not how much you studied, it is which memory system you wrote it into. Information you studied once is stored as fact. Information you rehearsed until it became automatic is stored as identity. Cortisol cannot close the gate on identity. It can only close the gate on effort. What you have been calling a memory problem was actually a storage problem. The information was there. It was just written into the wrong system. Have you ever noticed that the things you truly know, not just remember, but feel in your bones never disappear under pressure? That is not confidence. That is your basal ganglia staying fully online while your hippocampus negotiates with cortisol. That is biology. Your mind going blank under pressure was never a flaw in your design. It was cortisol running a survival protocol. It was your amygdala protecting you from a threat your rational mind knew. It was not real, but your biology could not tell the difference. Two memory systems responding exactly as they were built to respond long before exams and presentations ever existed. The hippocampus pulled back, the threat system took over. And the only memories that made it through were the ones so deeply embedded in your biology that they no longer lived in conscious recall. They lived in who you are. This was never about intelligence. It was never about how hard you prepared. It was about which memory system you were building and whether cortisol had a key to it. Now you know the mechanism. You know the gate. You know exactly where your memories go when pressure hits and why they were never actually gone. Ask yourself this: how much of what you know do you truly own, and how much are you only borrowing until the pressure comes? This was just one mechanism. There's a whole channel waiting for you, and I have a feeling the next video is exactly what you need to see.